Let's simplify this radical expression. You can see here I have something that's already on the outside. And then I'm going to see if I can simplify these things on the inside. I notice that I have a number and a variable, so I like to split those up. I'm going to call this the square root of 12 and the square root of x to the 5th. Okay, you can do that as long as they're multiplied and as long as there's no plus or minus in between here. So the square root of 12, do I know the square root of 12? Well, I come look at my perfect squares over here. I don't see 12, but do any of my perfect squares go into 12? Why, yes, 4. Okay, 12 is 4 times 3. And I know the square root of 4. So the square root of 12 is going to become the square root of 4 times the square root of 3. And what about this square root of x to the 5th? I know I'm looking for groups of 2, and that's not a group of 2. So I'm going to rewrite this as x to the 4th, square root of x to the 4th, and square root of x to the 1st. Okay, because these two together do give me x to the 5th. Now I can simplify these two that are underlined in orange. Okay, I'll bring down my 3x. What is the square root of 4? 2. Square root of 3 drops down. What is the square root of x to the 4th? X squared. And then the square root of x. Let's put it together. Put all the things under the radical back under the radical and bring everything else out in front. So out in front, I'm going to have a 3 times 2. That's 6. And I'm also going to have x times x squared. Okay, if you remember the product rule, x to the 1st times x to the 2nd, you add those exponents together, that gives you x to the 3rd, right? 1x here and 2x is here. And then what's left under the radical? 3x. So here's my answer. 6x to the 3rd, square root of 3x. Radical.